as the patriots are well aware, whenever you hang a United States flag, you always hang it up with this blue field right here in the corner. All right, you always got to hang that up like that to where this is in this corner up here. All right, and that so that the alternating red and white stripes flow down. All right, that's because this right here represents heaven. See that? These stars in the sky. That represents the heavens. Okay, these alternating red and white stripes represent fire coming down from heaven. All right, so you ask, why does the United States flag represent fire coming down from heaven? All right, well, you guys have to remember the whole scenario here, because there's something happening. They're aware of it, being aware of it, and ain't too inclined to let you know about it. But fortunately, y'all got this presentation. All right, now what's gonna happen is that on the day that the moon and the planet Venus eclipse the sun, all right, the combined gravitational pull, see, that's ultimately because in the summer of 2012, we're probably going to be at about 7 degrees, all right? We're going to be teetering. But when that alignment takes place, it's going to pull the earth, bam, to where we stand straight up. And on the day that the earth stands still, that's the day that the earth stops generating a magnetic field. And if we're not generating a magnetic field, then there's nothing to stop that fire from coming down to the earth in the sight of man and burning up everybody and anybody that's on the surface of the earth on that day. Now, since everything in space happens in cycles, in predictable cycles, and everything happens over and over again, I don't care how bad you are, how mean you are, how many nuclear weapons you got, how much you doubt me, ain't nothing gonna take away from or add to the cosmological order. You're not gonna stop this planet from rotating once on its axis once every 24 hours. You're not gonna stop the moon from doing this thing every 28 days. You ain't gonna stop the earth from going around in that 365-day cycles. You're not gonna stop that. You're not gonna stop the planet Venus from eclipsing. All right. So there's nothing that you can do to change that. That's what happens. The only thing you could do is be prepared for it. And if you're not prepared for it, that means you one of the dumb monkeys that was at the club when this presentation was being given. All right? Or you just didn't believe it. Or you chose not to believe it. Either way it go, when the earth stands still, it always stands still in the same spot. All right? That's why the United States is referred to as the phoenix. The phoenix is a bird that's burned, and then it rises again from the ashes, and then it gets burned again, and it rises again. It's a perpetual cycle. All right? This ain't the first time it done happened. It ain't the last time it happened. All right? Okay, now we're going to revisit something real quick here. And watch this. It says, every few thousand years, the magnetic field changes intensity and reverses. Okay? Now, the question becomes, why does it change intensity? So what they're saying is that the magnetic field either gets weak or it gets stronger, but it changes in intensity. Now, here in this document, okay, under here it says, orbital variations of the Earth cause changes in the amount of incoming solar radiation known as Milankovitch cycles. Shown here are changes in the eccentricity of the orbit, the tilt of the spin axis, nutation, and precession of the equinoxes. All right. So what they're saying is the degree of the Earth's tilt changes the amount of incoming solar radiation. All right. Now, the reason why is you guys have to remember the Earth is a generator. All right. And it's generating electricity. All right. Now, it's generating that electricity based upon its spin rate. If you take any type of generator, Alright? You take this generator, alright? The faster you spin it, the more electricity it's going to produce. Just like the windmill, the faster you spin it, the more electricity it's going to produce. If you spin it slower, then it's going to not produce as much electricity. Alright? So the same principle applies to the earth. Alright? When the earth is at 23 degrees, it spins at a rate to where it's producing enough electricity to block 100% of that solar radiation. Alright? That cosmic wind. So if you take the earth and you decrease its tilt by 7 degrees, what you do is you're messing with the rate at which it spins. So 7 degrees less means that it's a 7-degree decrease in the amount of electricity that it's producing. Alright? Now, say the earth decides, I'm not going to produce as much electricity as I was producing. Alright? The sun is not going to be like, okay, me too, I'm going to stop too. Nah, he going to keep pushing, doing what he doing. What, you slipping? You ain't generating all that electricity? So now what happens is some of the electricity that was coming off of the sun, alright, is breaking through that barrier because this barrier isn't as strong as it used to be. So that's why if you change the tilt, you affect the spin, thereby you affect the amount of electricity that the earth is generating, and you affect the amount of electricity that the earth is blocking. Alright, so the closer you get to zero, the less electricity that the earth is generating, until you get to zero, where the earth is generating zero electricity. Alright, so on that day when the earth stops producing the electricity, then all of this is coming in on us. Okay, and whoever has the misfortune of being in that hot spot when it happens, for the period of time that the earth stands still, you're fried. And it just so happens to be, it's going to stop right over here, right where you live, Mr. and Mrs. America. Okay, here we have a book called A Thin Cosmic Rain, Particles from Outer Space. Okay, they're showing the earth, and then they're showing the cosmic wind, alright, hitting the earth. Okay, and fortunately our magnetic field operating properly and everything is deflecting that. It's not getting in. Alright, but whenever some of those particles enter into the earth's atmosphere, they call it cosmic rain. It's particles from outer space. Okay, cosmic ray, Wikipedia, the free encyclopedia. When cosmic ray particles enter the Earth's atmosphere, they collide with molecules, mainly oxygen and nitrogen, to produce a cascade of lighter particles, a so-called air shower. Alright? I need y'all to know that, because that's important. Okay? So basically, what we have here is when radiation enters into our atmosphere, okay, and comes down on the earth, they call it cosmic rain or an air shower. Okay, so that means for the period of time that the earth is off its axis, is away from that 23-degree mark, going towards zero, that means the closer we get to zero, the more cosmic rain is going to flood the earth. It's going to shower us. Okay? By now, I imagine some of you should be pulling your hair out, trying to figure out how in the heck did this dude come up on all this information? Who is he? Where'd he get it from? Who he been talking to? Do we gotta go shoot some Freemasons for giving up the secret? Well, no. If you recall, in December of 2008, the government and broadcasters started issuing warnings to individuals that by February 17, 2009, you need to have your converter box. If you don't have your converter box, you will no longer be able to receive certain analog signals. Remember that? Okay, here it is. Digital television on Wikipedia. It says, by special dispensation, some analog TV signals ceased as previously scheduled on February 17, 2009. Now, for me, that date bears a particular significance, and I'm going to get to that in a second. I just wanted to show you that that was the day that they stopped broadcasting some of the analog TV signals. In order to understand why they had to change the manner in which they transmitted the analog signal, you have to understand how they transmit an analog signal. The ionosphere is the uppermost part of the atmosphere, distinguished because it is ionized by solar radiation. It plays an important part in atmospheric electricity and forms the inner edge of the magnetosphere. It has a practical importance because, among other functions, it influences radio propagation to distant places on the Earth. It is located in the thermosphere. Okay, now basically what they said is that the air that we breathe is located here. It goes from the surface all the way up 85 kilometers. The air that's 85 kilometers above the surface of the Earth is out in space, and it's touching some of the ionized radiation, some of the electricity that's coming off of the sun. So that means that the outer part of the air that we breathe is electrified. Now what that means is, through radio propagation, and radio propagation is a term used to explain how radio waves behave when they are transmitted or are propagated from one point on the Earth to the other. Analog is just another word for radio propagation. Radio waves are sent through the air, so that means the analog signals are sent through the air. It says radio propagation in the Earth's atmosphere is affected by daily changes of ionization in the upper atmosphere layers due to the sun. So basically what they're saying is, occasionally the sun will burst forth a flare, and since the Earth is only tuned to deflect a certain amount of electricity, whenever the sun produces excess electricity, that excess electricity gets in. And what happens is, when this layer comes into contact with that excessive electricity, then this layer becomes hyper electrified. So whenever they try to transmit a signal using the ionosphere, all you get is static electricity. And the reason why is because normally an analog signal is transmitted from tower to TV. That's why, like on the mountains, you have giant television towers and radio towers, because they're sending that signal out to the group of people who are in range of that. Now, say for example, you have ABC, NBC, CBS, and they have stations here, and they want to transmit all the way around the world. They don't just want to transmit to a small group of people. So what they do is they build a giant tower, and instead of sending the signal from the tower to the TV, they send the signal into the ionosphere. And since the ionosphere is electric and signals travel in an electric environment, then the signal actually goes all the way around the Earth. So if you're on this side of the planet and you want to watch ABC, NBC, CBS, then all you need is a antenna, and you can receive the signal straight out of the atmosphere.